In this video, I will walk you through an AP exam style question involving position, velocity, and acceleration. Particle Q moves along the x-axis. Its position at time t with t greater than or equal to 0 is given by q of t equals e to the 3t minus 2t squared. Part A. For what intervals of t with t greater than 0 is particle Q moving to the right? Justify your answer. Here's a fact that you need to have memorized to answer questions like this. A particle will be moving to the right when the velocity is positive, and the particle will be moving to the left when the velocity is negative. So our strategy is, let's take the position function and use it to find the velocity function. And then we'll make a sign chart to see where the velocity is positive and where it's negative, and then we can answer the question. First, we need to find that velocity function. We know that velocity is the derivative of the position function. So we're just going to take the derivative of this. We know that the derivative of e to the something is e to the something. It doesn't change, except we always have to do the chain rule. Because the exponent is not just an x, we need to multiply by the derivative of that exponent. And that will be 3 minus 4t. To make a sign chart, we need to find the critical values where the velocity is equal to 0. So looking at these two factors, I can see that the factor of 3 minus 4t, if we set that equal to 0, that's going to give us 3 is equal to 4t, which leads us to the critical value t is equal to 3/4. We should also set the other factor equal to 0. However, there is no exponent that will turn e into 0. So this has no solution, and t equals 3/4 is our only critical value. When you set up your sign chart, you will have a row for each factor, and I'm going to put a line at the critical value of 3/4. We can tell that the factor of 3 minus 4t is going to be negative for any value of t that is greater than 3/4. So I'm going to put a negative here. For example, if t was 1, then this would be 3 minus 4, which would be negative. And similarly, this factor will be positive for values of t between 0 and 3/4. I'm not going past 0 because t is greater than or equal to 0. There is no exponent that will turn e into a negative number. Even if I had, for example, e to the negative 3, this would not be a negative number. This would just be 1 over e to the third. So this expression will always be positive. A positive times a positive is a positive, so velocity will be positive in this interval, and a negative times a positive is a negative. So velocity is negative in this interval. So that means that the particle will be moving to the right between 0 and 3/4, and the particle will be moving to the left when t is greater than 3/4. They only asked when q is moving to the right. So we say particle q is moving to the right on the interval from 0 to 3/4 because v of t, which equals q prime of t, is positive. Notice that instead of just saying that the velocity is positive, I went out of my way to mention the position function, q of t, in my justification. That's because they did not give us the velocity function. They gave us the position function. So I always want to refer back to the actual function that we are given in my justification. Part B. Find the acceleration of particle q at time t equals 1. Well, we know that acceleration is the derivative of velocity. So let's take the derivative of this velocity function. The velocity is a product, so I will have to use the product rule. The first time through, I take the derivative of the first factor. The derivative of e to the something is still e to the something. So I will have e to the 3t minus 2t squared. However, the chain rule demands that I multiply by the derivative of the exponent, which will be 3 minus 4t. So all of this is the derivative of the original function. So the first time through, I leave the second factor alone. So I'm just going to bring down the 3 minus 4t, unchanged. And then I put a plus, and I sort of go through it again. The second time through, I leave the first factor alone. So this time I'm going to leave e to the 3t minus 2t squared alone. And I'm going to take the derivative of the second factor. So the derivative of 3 minus 4t is just negative 4. So this is an expression for the acceleration. In a moment, we will need to evaluate at time t equals 1. So I think it will be easier to do that if we simplify a bit first. I'm noticing that we have a common factor of e to the 3t minus 2t squared. So I'm pulling out that GCF in the front. So that leaves behind all this. Of course, 3 minus 4t times 3 minus 4t is 3 minus 4t squared. So now we can use this equation to find the acceleration at time t equals 1. We will just substitute 1 for all of these t's. Replacing all the t's with 1's, we get this, which equals this. Negative 1 squared is positive 1, minus 4 is negative 3. So we end up with negative 3e. Just to be on the safe side, I want to refer back to the given function q in my final answer. So I will say a at 1 equals v prime at 1, which equals q double prime at 1, equals negative 3e. Particle r also moves along the x-axis. At time t equals 0, particle r is at position x equals 2. Particle r's velocity at time t with t greater than or equal to 0 is given by v sub r of t is equal to 1 over 1 plus t squared. Part C. Find the position of particle r at time t equals 1. In the chain of calculus, it goes position, velocity, acceleration. I can move to the right by differentiating, taking the derivative. I can move to the left by integrating, finding the antiderivative. In this case, they gave us a function for the velocity of particle r. And they're asking me about the position of particle r. So I'm going to have to integrate to find a position function. So the position function will equal the integral of this velocity function with respect to time. But this is a memorized rule. We know that the integral of 1 over 1 plus t squared is arctangent. Let's use this initial condition to find the value of c. At time t equals 0, particle r is at position x equals 2. So if I plug in 0 for t, it should equal 2. So that means arctangent of 0 plus c should equal 2. When you evaluate arctangent 0, you're thinking tangent of what is equal to 0. And we know that the tangent of 0 is equal to 0, so that's the arctangent. So we get 0 plus c equals 2, which means that c is equal to 2. Let's go ahead and put this value of c back into the position function. So now we have the position function. To find the position at time t equals 1, we just need to evaluate r at 1. So this is arctangent 1 plus 2. When you evaluate this, you're thinking the tangent of what is equal to 1, and that's pi over 4. So this is the answer. Particle r has position pi over 4 plus 2 when t equals 1. Part D. At time t equals 3, is the speed of particle r increasing or decreasing? Give a reason for your answer. Here are the notes that you must have memorized in order to answer a question like this. The speed is increasing if velocity and acceleration have the same sign, and decreasing if the signs are different. So we need to find the velocity at time t equals 3 and see if it's positive or negative, and we need to find the acceleration at time t equals 3 and see if it's positive or negative. If the signs are the same, speed is increasing. If the signs are different, speed is decreasing. We can easily find the velocity of r at time t equals 3 because they gave us a function for it right here. The velocity at t equals 3 is 1 over 10, but what matters is this is positive. They did not give us the acceleration function, but we know that acceleration is the derivative of velocity. In order to take the derivative, I am going to first rewrite the velocity equation as 1 plus t squared to the negative 1 power. So I'm just going to use the chain rule. When I take the derivative of this, the negative 1 will come out in the front, and this will become the negative 2 power, and I still have 1 plus t squared on the inside. But chain rule, I now will multiply by the derivative of the inside, which is 2t. Simplifying this a little bit, we get negative 2t over 1 plus t squared squared. So here is an expression for the acceleration at time t equals 3. I've just substituted 3 for these t's. I don't actually need to simplify this. All I care about is whether this is positive or negative. And everything you see here is positive, but then there's a negative sign in front. So I know that overall the value of this expression is negative. So notice that the velocity at 3 was positive. The acceleration is negative. Since the signs are different, that means that the speed is decreasing. We say the speed of particle r is decreasing at time t equals 3 because the velocity of r at 3 is positive and the acceleration of r at 3 is negative.